Hi Chenfo, my name is Yanga and I'm from Vulea SSP and I would like you to help me with this question.
Hi, Younger there at home. So remember, guys, if you send more questions to us via WhatsApp or via the app, which is the option that I said I'm going to tell you about, remember you stand a chance to win a TV set, which is courtesy of Tenfold Live. So please send more questions to us. Right about now, the person who sent a video and we liked it and has won the TV, the lucky winner that we have is Yanga. So Yanga, congratulations to you for winning that particular TV. But for now, let's look at the question that you sent through and try and assist you with it. It says, in the diagram, D is a point of AB it says in the diagram, D is a point on AB of triangle ABC, and then C is joined to D. BC squared is equal to AB multiplied by BD, and BC times CD is equals to BD times AC. And then I want you to prove something there. But before we can go there, the first thing I want you what I want you guys to please be thinking about in this particular question is that as soon as I give you ratios multiplied by each other, then you must know that we have what we call similarity of triangles. Having similarity of triangles would then mean that you have sides in proportion and also you have angles in proportion. The reason for angles in proportion, we normally use the word equingular. And then with the sides, we always just say sides in proportion. Now, I've already showed you, or rather the statement has already said that the sides are in proportion. So you don't have to worry about that. It means there are two triangles that are similar to each other, which we got that proportionality from. So then what would that mean is, the first question I want you to do is prove that AB multiplied by CD is equals to BC multiplied by AC. So what I want from you guys will be, where's my AB? So I have this is B, ne? So please, this is B. I just made a mistake there. It's not actually R, so that's B. Now I want you to tell me that AB multiplied by the CD, which is this, it is equals to my BC will be this one multiplied by AC, which is that length there. So I'm just trying to show you which pairs by using these two different colors. The yellow would be what's on the left hand side of the equal sign, and then the green will be what is on the right hand side of the equal sign. Now let's get to actually solving this particular thing. Now first let's look at what we are given up there. So we are given that BC squared is equals to AB multiplied by BD. So BC squared is AB multiplied by BD. Now, what I want you guys to please know about this as well is, as soon as I say BC squared, I am talking about two triangles that are similar to each other, that are sharing one side or that have a common side. The common side here will be the BC. So there's two triangles which both have BC. That's where we get that from. So this will be the same as BC divided by AB, which is equals to BD divided by BC. Now, what this would mean is, it means that therefore I have triangle A. Let me just write properly there so people can see at home. I have triangle ABC being similar to, please remember that similarity would mean that we are talking the vertical lines. This is similar to CBD. So triangle CBD. Now, how I come about this, it's because my ratio here is supposed to be BC all over AB, which is equals to BD all over CB or BC. So remember, what the proportionality is on this triangle must be the same as the proportionality on this triangle. So hence I have those two there. So if I have that, so let's look at this quickly. So if I have that, it would then mean that one of the other proportionalities I can have here will be AB, because I want AB over, I also want AC. So AB over AC. Now let me try and just erase this part up here. Okay, so I want AB, which will go with the BC, 1. Also, I want AC, which will then go with the DC there. So it will then be AB over AC is equals to, remember we said it goes with BC divided by CD. And remember, the order of the letters really goes with what the alphabets are. So A comes before B. That's why it starts as AB instead of BA. Therefore, you then cross multiply here, then I will have AB multiplied by CD, which is equals to AC multiplied by BC. AC multiplied by BC. So let's just try and see if that's what they wanted. Do you see? So what I have up here, which is what they wanted me to prove, is AB times CD, which is there, is equal to BC multiplied by AC. Remember, multiplication, it doesn't matter which one comes first, because the 3 multiplied by 2 is the same as 2 multiplied by 3. So that's why that is still the same as that. Move on to the next question. I hope, Yanga, you are listening and you are hearing what I'm trying to say to you and everybody else at home. Now, the second question they are trying to say, prove that BC is a tangent to the circle ADC at C. Prove that something is a tangent. What I want you guys to understand, there's 2 things happening here. The fact that it is a tangent will be a conclusion that you're going to make. It's not what I want you to prove. What I want you to prove is I want you to prove whether 10-chord theorem exists or not. That's what you need to actually prove. So your RTP is not that it is a tangent. That's a conclusion you're going to make. What you need to do, the RTP, is to prove what makes it a tangent, which is the 10-chord theorem that I just mentioned right now. So back to the question, if I want to prove that BC is a tangent, I will roughly draw a circle here. So the circle will look something like this. It's a rough diagram, please. I know it doesn't look like a circle, but hey, we're still talking about a circle. Roughly my circle will be like that. So remember, if I have that, it means that I must prove that this angle here is equal to that angle there, because it will then represent what we call the 10-chord theorem. The angle between the tangent and the chord is equal to the angle in the alternate segment. So that's what I'm trying to do. So here I will say my RTP will be C2 is equals to A. But now let's try and see what is it that we said from the previous question. Remember what we said from the previous question? We said that ABC is similar to CBD. So that's what we're going to work from. Now, this is the proof. With the proof, I said triangle AB, triangle ABC is similar to triangle CBD, right? So if I am saying this, it means that, remember what similarity has to do with. Similarity has a few conditions that you guys need to be knowing by now. You can talk about sides being in proportion, which is what they've given us to claim similarity. If things are similar, it would then mean that the angles, the corresponding angles in those 2 triangles will also be equal to each other. That's one thing that you also need to know. And then thirdly, it means that if it is similar, then there will be some correspondence that happens between the 2 triangles, because it gives us ratios that you can work with. But in this instance, I'm focusing on the second point of angles, because I'm trying to prove 2 angles to be equal. So what would that mean is, remember, the angle at A will be equal to the angle at C. That's what correspondence means. And then the angle at B will be equal to the angle at B. Lastly, the angle at C will be equal to the angle at D. That's what similarity says. Therefore, in this triangle ABC, which is the big one, here, just remember, please, that this is actually B, not R. In triangle ABC, I am saying that there is angle A in ABC, and it is equal to, in triangle CBD, is equal to the angle at C, which is what I've indicated with my dot down there. Therefore, you will then say A is then equals to However, I think we need to start, before we start, don't start with A, start with the C, because remember, angle between a tangent and a chord. So we start with the angle between the tangent and the chord, which is C2 is equals to A, and then your reason for this will be equingular. So that would be the equingular part of it. So that's what we are trying to say. Now, what we've looked at right now, guys, is we are given proportionality. If we're given sides in proportion, it would then mean that we have two triangles that are similar to each other. That's number one. Number two, we are given the issue of having b squared. B squared would mean that we have two triangles that have a common side. In this instance, the common side will be the BC. And then lastly, we then need to prove tangency. Tangency, you will then say, therefore, quickly, just to conclude this, I will then say BC is a tangent. Then your reason will be converse of 10 chord. Converse of 10 chord theorem.